a few megawatts to almost close to 60 gigawatts, and wind around 10 to 12 gigawatts to 40 gigawatts now. And not only in our country, but in many parts of the world, the same is happening. But one critical question is going to be the operation of the RE and its response to disturbances in the grid is an important issue. Which our colleague CM Narasimhan is going to agree on this particular one. And this is an issue we need to address. This is precisely what we need to understand the variability, intermittency, and also how exactly manage the grid. And one important aspect what is seeing over a period of time is the curtailment of the generation from both from wind and solar is a growing concern. Please remember the investment is made for generation and the generation getting curtailed. The investment is going for whatever the returns they are expecting is not going to happen. This is precisely why there are many things are happening, including making the virtual power plants and combining the wind, solar, the battery storage, and making it a virtual power plant. These are the kind of technologies talking about. But all these things revolves around to need a forecasting. The forecasting will become an important aspect if you want to operate the systems. Of course, I don't want to say much on this need part of it. Everybody knows. But one critical question I am trying to see very clearly is the forecasting. The forecasting, not just we are trying to talk about the near term, but it's also long term is an important aspect of it. Near term, 5 to 60 minutes, we are trying to talk about for regulation, real time dispatch, distance, everything. And we have there lot of methods are available in this particular one, including the no costing. And definitely, it's not a big issue today in a talk of forecasting on this particular phenomena. And very short term forecasting is also for load following, near term unit commitment, hydro mixing, every aspect of it. Again, here also we have good models available. Short term forecasting is another area where we already started working on unit commitments, using market trading. This is also well established. If you try to see first three part of it, in the last 4 to 5 years, we have seen a lot of models coming up, and we could improve the forecasting from 85% close to around 96% today in the intraday. And if I try to talk about day ahead, we have gone up to 92 to 93% on day ahead on 15 minutes time frame. And I'm talking about an average MAPE. But very important aspect is going to be the medium term, long term. This is the one area where you're finding a lot of issues coming up. As on today, we don't see any models available for medium term forecasting, particularly what we are trying to talk about for resource planning, condition analysis. We are trying to talk about, say, 6 months to 1 year down the line, how it is going to be. So, this one area with us, lot of research studies coming out. There's a variation in the wind, variation in solar, the generation is coming down from the wind, generation coming from solar. These are the distributed phenomena coming up. We need to start working on the good models to predict both in the medium term and the long term. This is one area we definitely see a lot of work to be done. I'll stop at this stage just to see a context setting, and further I can go for what are the models done in DV. But at this moment, I'll stop here.
Thank you, sir. You want to unshare your screen?
Yeah. Just I'm trying to unshare the screen.
Yeah.
Unshare is not happening. Especially, I'm saying, okay.
Otherwise, I can ask the host to unshare if there is any difficulty.
No, it's already unshared. You can
Yeah.
try.
Okay. Fine. Yeah. Now, can I request Sri Dr. Narsimhan, CMD?
Yeah, right. Thank you. I'm not a doctor, so just so. thank you, Mr. Raghavendra. Thank you, IMD and NCMWRF for having me here on this panel, and it would be, interesting set of discussion over the next couple of hours. So I'll just share my screen. Dr. Balraman has set the tone for the main theme, and what he mentioned about the medium term and long term, that's very crucial, especially considering that we have a very ambitious rollout of RE. Yeah. So my focus would be, we have to operate the system on a day-to-day basis, and we would essentially be looking at the short term. But yes, the medium term and long term is important because each weather year is different. 2019, 2020, we had an instance of wind drought, and so these type of phenomena are also becoming increasingly frequent worldwide. So my focus would be on the short-term forecast and how it's important for operating the system reliably. Of course, the impact of weather on power demand, that's been well researched over the last several years, and we have seen some of that in the April to June. We had a situation of heavy power demand because temperatures were historically the highest in 122 to 126 years in many parts of the country, and the demand it went up to 215 gigawatt, and we could meet 211 gigawatts. So there was some amount of shortage at that point of time. So so 211, it's essentially mainly temperature driven. We had very less instances of western disturbances during this summer, and this steady high temperature conditions that led to the increase in demand. But on the RE side also, it's
Slide.
gradually becoming very important.
Sir, slides are not moving.
Yeah, let me, I'm
Still on the
just,
first slide.
yeah, let
Okay.
me see. Has it moved? Yeah,
Yeah, now it is in second
yeah,
slide.
yeah. So, so I would basically be talking about the forecasting, what we do today and what all improvements can be done and how it impacts grid management. So this atlas is well known. The important point I would like to emphasize here is that if you see the solar potential, that's mainly on the western part of the country, and that's the reason why all the development of solar parks which are happening are essentially happening around this. 3 decades back, when we were talking about coal, most of our coal reserves were essentially located in the eastern part of the country. And so most of the transmission which we were building was from transferring power from east to west and north to south. Now the direction would reverse with so much of wind and solar getting added. In fact, most of the transmission lines, their behavior would be completely different. In the daytime during high solar, we would have power flow from west to east, and during the off solar hours, it's from east to west. So that places a lot of challenges as far as system operation is concerned. Earlier, we used to just people used to study only the peak and off peak profiles, but that's no longer the case. 8760 hours is something like each hour would be different and it would vary from day to day. And so similarly, the wind potential is also on the western part of the country, and so this, from the transmission planning and operation perspective, this becomes very important. And today we stand, all these targets are known. So coming to where we stand today in terms of penetration, we have some states like Karnataka, which have already achieved 132% instantaneous penetration, which means that over and above their load, they're also exporting to rest of the country. That's the kind of penetration we have achieved in 21, 22. Similarly, Andhra and Tamil Nadu. So all this, we have these states which have a very high RE penetration. But of course, globally, on an annual basis, it's just about 9.5% wind plus solar, and maximum daily energy is of the order of 18%, and instantaneous 27% was achieved in 21, 22. But very recently in May, 22nd May, we achieved 32% instantaneous penetration because that was a day when we had very high wind and solar coupled with a drop in demand due to a western disturbance affecting the northern region. Okay, so now coming to this, we have about close to almost 160.9. This includes large hydro also. But essentially, if we add only wind and solar, we have close to, let's say, 1621 here and this. So we have about 89 gigawatt of wind and solar, which we are monitoring at the RLDCs and National Load Dispatch Center. But the figures in blue, these are the ones that we are actually responsible for scheduling. So that's close to 19 gigawatt. So 19 out of 89 is what POSOCO schedules through its regional load dispatch center. But this number is only going to grow up because most of the new additions, they are happening at the interstate transmission level where we would be responsible for scheduling. Okay. So we have renewable energy management centers at all these high RE states, renewable energy states, and also at the 3 regional load dispatch centers and national level, we have a renewable energy management center. So as I mentioned, we are monitoring about 89 gigawatt of wind and solar capacity, out of which 19 is at the interstate level coming under POSOCO, and intrastate 70 plus wind and solar, that's coming under all these state load dispatch centers. And we have the real-time RE generation also. And forecasting today, what we have is we have one weather service provider, 3 external forecasting agencies, and we also have an internal forecasting tool, and we have a combination and aggregation tool. That's what is the status today. And there's a scheduling platform also for renewable energy where the developers are also able to enter the schedule. So we have a scheduling at 15-minute granularity. And so each day we have 96 time blocks, and wind and solar. So essentially, the forecast that we do at the NLDC, RLDC, and state load dispatch center level, the objective is entirely different. The objective is basically ensuring secure grid operation. And we also have the wind and solar generators who are also forecasting, but their forecasts are for a different purpose because that's for commercial liabilities, payments and liabilities that arise. That is out of the wind and solar generation forecast given by the developers. Of course, the developers have an option to take the forecast that we put out, but they are generally going by their own forecast. They have their own forecast service providers providing that. So Dr. Balraman talked about this load following scheduling. So if you look at this 24-hour profile, so if you look at a slightly long term, this is basically load following. But if we try to zoom in on any particular section, you'll find that there is lot of changes. That's where the regulation services, the automatic generation control, that comes into picture. And this is the load following, so where we need ramps also. And so we have basically, day ahead forecasts. Why is day ahead forecast important? Because India, as we all know, the coal fired units, they are currently the mainstay. So if we have to bring in a new coal fired unit, we need about at least a 7 to 8 hour notice. That's where the day ahead forecasts become very important, because if we find that there is a reduction in wind and solar generation forecast for the next day, then we have to bring additional thermal units, for which instructions need to go out to all the players. So that's the day ahead forecast, mainly for unit commitment. And intraday forecast, we can use that for bringing in gas and hydro based units, which need just half an hour to 1 hour notice. And intraday forecasts are also very important, because we can, if we schedule properly, then the pressure on regulation services, the automatic generation control, that would reduce. And of course, curtailment was one issue, like if we end up having too less of coal-fired units and RE has gone down, then we will have load shedding. But if we have too much of coal-fired units on bar, they have to operate at 55%. So that's the inflexibility that we have. We could end up having some amount of curtailment of RE generation. So of course, forecasting various techniques are there, but when we look at the day-ahead forecast, we are going by the numerical weather prediction. So we don't really have on-saw method today. We have just one deterministic forecast that we get on a day-ahead basis, and it's updated twice a day. So totally we get one at 11 a.m. and one at 11 p.m. We are getting the day ahead forecast. So we don't we will also have to further understand the onsaw forecast, which different models give us. And so definitely a lot of interaction would be required with the IMD team on this particular issue. So definitely the forecast errors, that would depend on many things. If you're looking at a longer time horizon, definitely the forecast errors would be very high. But as we move towards the real-time operation, there is since we get a lot of field level data also, so there are statistical corrections deployed, and the intraday forecast errors are much lower. And of course, for wind, there are many local effects also. For solar, cloud cover becomes very important. That is so definitely during the monsoon period, the forecast errors, they tend to be a little higher than on a clear day. And geographic diversity of RE. So over a large area, definitely there would be some cancellation of forecast errors. And data quality, that also becomes very important, both the real-time data as well as the weather data. So this is just an example of a solar park in Rajasthan, where on a typically cloudy day, uh, uh, we have seen that there is a lot of fluctuation in the solar generation, and this actually on a day-ahead basis, this becomes quite difficult to forecast. But intraday, definitely we try to reduce. But this is one area where we still have to get the things right, and similarly, if you look at wind, you'll find that, let's say, the forecast revision 0 that I mentioned. So on a day-ahead basis, the forecast which I got for wind was something like this. Okay, so it was a very optimistic forecast, but on a um, intraday level, the last revision, the green one. So this is the green curve. So on an intraday forecast actually came down, and this was evident that if sufficient resources are not pressed, then we could end up having a frequency decline during some period, which we had for a very brief period during the evening, because the forecast was high, we didn't commit enough units, and there could be problems. So this is something that we need to really, the day-ahead forecast also, that accuracy becomes important, considering that we have a lot of coal-fired units. But again, that we are trying to attack that in various ways, because currently we are looking at cold restarts, but the moment we have hot restart, we just try to keep a coal-fired unit closed for a few hours. Then it's very easy to bring it back quickly. So all that, this particular wind season, Tamil Nadu has already tried this out for some of their coal-fired units. They have closed it during the high solar hours, and during the evening they have brought it back. So this type of strategy would, of course, it would involve a lot of changes at the power plant level, their operations. And if you look at the monthly pattern of wind generation, so I mentioned about 22nd May when we had a record wind generation. We got close to 25 gigawatt, and 54 gigawatt wind plus solar we integrated on that day with minimal level of curtailment. This is by far the highest so far, and without uh, very marginal curtailment, we could successfully integrate that. And then, of course, eclipse is another phenomena, but eclipse, unlike a cloud cover, eclipse is much more easier to forecast because we have the obscuration, we have all the IMD websites. So this particular solar eclipse, the report is available on our website. So we could get quite a good forecast of the reduction and the ramping rates, and we could successfully uh, overcome this eclipse, but again, as we have more and more of solar, I think the next eclipse is going to happen 2034. So that's something where we will have to be, we should have enough resources. The problem with solar eclipse is that once the eclipse has passed, then the increase in generation is very fast, the ramping. So ramp up rate, as you have seen, it's quite high, and uh, of course, many a times we might need to actually change the inverter settings to have a lower ramp rate, So that's something which we would require as we have more and more of solar generation. And we have uh, captured all the data also of the solar irradiance with respect to obscuration. Generally, it is a very linear uh, profile that we get, linear, except for very the smaller, 0 to 10%. During that obscuration factor, it's not linear, but otherwise it's by and large linear. So why for the RE forecast, it's important is that I mentioned that the wind and solar developers, they are also forecasting, because for them, the errors, higher the errors beyond plus minus 15%, there is a penalty for all that, as per the Central Electricity Regulatory Commission. So for them, it's important that they ensure that the errors remain well within plus minus 15%, and very soon this is going to go down to plus minus 10%. So as long as they are within this range, they get their full rate, whatever is their power purchase agreement rate, they get paid for that. But the moment there is a increase beyond that, they will not get paid their full PPA rate. So this is the uh, chart which is there. And there's one important thing that for solar and wind, the forecast error formula is entirely different. In the denominator, we have the available capacity. So if you have a 100 megawatt solar park and all the inverters are available, the available capacity would be treated as 100. Though the forecast for a particular time may be just 50 megawatt, but the error is all captured with reference to available capacity. That's the worldwide, that's the trend. And of course, there is a request from many of the stakeholders that the denominator should actually have the forecast value, not the available capacity. So, of course, we have all know that forecasting over a larger area, all the errors get cancelled out. So this is just an example of the error duration curve for one single solar park. The same thing for if you aggregate for the entire solar park, the errors come down. And one important thing which would be seen is that the developers, we have seen that most of the developer, if their errors are generally much lower than what we are getting, because of course our systems are up since March 2020 only. So as more data gets into the system, the forecast error would definitely come down. But so this is the developer duration curve. And if you look at the state as a whole, the errors further reduce. Of course, we use the aggregated error only, for the purpose of our reserve estimation. But of course, in the grid code also, there are provisions that one could try to have the forecast error over a larger area for the pooling station, either at the pooling station level or at the state level. Already in Karnataka and Andhra Pradesh, the State Regulatory Commission has, the forecast errors are worked out for the state as a whole. So similarly, we have. So this is what I would like to mention, that we are just at the beginning of the learning curve as far as RE forecasting is concerned. Much more work is required to be done. We have a MOU with IMD in this direction. And so weather accuracy, cloud cover, eclipse, cyclone, real-time data, even cyclones, typically, we have a sudden increase in wind generation, but it is possible that the moment the wind speeds exceed 25 meter per second, a whole chunk of generation goes out because that's a cutout speed. So cyclones also, the wind generation, there is a lot of impact on wind generation. We see a momentary increase, and then there could be outage also of wind generation. And flexibility, we need reserves, and voltage control is also an important aspect, because depending on the renewable energy generation levels, certain measures are required for maintaining the voltage. And then as we move forward, the inertia of the system, that will also become, the moment we have less coal-fired units on bar, the inertia of the system would reduce. It's not a serious problem right now, but going forward to 2030, so this would also become very important. And this is being handled in several ways. Some of the countries, they try to, when they feel that the inertia levels are low, they try to curtail RE and try to bring more of gas-based units into the system. But there could be several other ways. Energy storage is one such alternative. And so the requirements to integrate large scale RE, of course, resource adequacy becomes very important. I mentioned that peak off peak, it's no longer the case. We have to entirely look at the 8760 hours landscape. And that's where what Dr. Balraman mentioned about long-term and medium-term forecasts, that would become very important. So we need to have the right amount of resources in the system, and energy storage is also one important feature. And then, of course, the wind and solar, the Dr. Balraman slide also, there was wind and solar also have to behave just like any other conventional unit. They should provide us frequency control, they should provide voltage control, black start services. That's an important this thing. And another part where we are still quite low on the learning curve is, of course, one reason for that is we just have about 7 gigawatt of rooftop solar. But as that number goes on increasing, we require some forecasting for the rooftop solar also, and simulation models and studies, that's also required. The on the weather side, there's a lot of research on simulation models and studies. We have a similar requirement even at the equipment level. So that's all I would like to mention. Thank you. Thank you.
Thank you, sir. That was a very comprehensive overview of all the challenges in the renewable energy as well as conventional sources. We had very nice presentations from two of our senior experts, and that has really set the ball rolling. Now I invite Dr. Nikhil from National Institute of Solar Energy to give his presentation. Dr. Nikhil?
Hello, sir. Can you
Yeah.
hear me, sir?
Yeah, you're audible.
Yeah. Thank you all. Once again, good morning, and thanks to NCMRF for having me here. In fact, the earlier two expert speakers have set the tone and almost covered most of the points on the weather forecast of RE generation. I want to share a couple of share thoughts, a couple of key points from my side. In fact, the first point is on the RE in India. In fact, last August we were celebrating our 100 gigawatt installed RE in India, and as on today, I think we have around 114 gigawatt. So that calls for a almost like approximately 1 gigawatt per month updation, which is happening in every month. And I think this kind of pace will demand the similar pace in the forecasting sector also, to ensure the stability and security of the grid. Always there is a myth regarding this RE generation, that wind and solar are too intermittent for reliable grid operations, and cannot be predicted. But I don't think so that myth is always true, because even in the last presentation also, sir was mentioning about the accuracy they have achieved in the predictions. And there has been intense research in the development of various machine learning models, especially the artificial neural network algorithms, which focus on the accuracy and the complexity, or reducing the complexity. Mostly the accuracies are generally quantified in terms of deviations, like mean bias error or RMSEs. So by integrating these variable renewable energy forecasting algorithms into system operations, the PSOs can in fact anticipate up and down ramps in variable renewable energy generation. This will help them for cost effective balancing of load and generation, both at the intraday and the day ahead scheduling. Also minimizing the curtailment of RE sources. There are typically like two aspects, both at the centralized level forecasting as well as in the decentralized forecasting. Centralized forecasting is mostly for system operators, which helps them in improving their network management and system balancing. And the other one is decentralized forecasting is generally for the renewable generators or the developers, which will give them a key advantage for the intraday and the day ahead electricity market trading in the electricity market. Coming to the various forecasting methods and applications, I think already there is a there was discussion on this. Typically, the physical methods are there, wherein the input weather data, which typically can be characterized as astronomical parameters, geographical parameters, and calendar parameters or meteorological parameters, and the air pollution indexes. So the accuracies of these input parameters are very important while doing the forecasting. And the applications, as was mentioning, depending upon the time horizon, there are various key applications. And as rightly highlighted by DG Nive, the short-term and medium-term forecasting is looking for a better accuracy levels. But my next point would be on the energy forecasting typically, because we talk about weather forecasting models, but the total system is actually a combination of both the weather forecasting and the energy forecasting, because the injection at the interface meters are more primarily taken for the calculation of the deviation, settlement, etc. So even though sometimes weather forecasting might be more accurate, but the energy forecasting is sometimes very challenging, and this requires very much like the plant characteristics data and the plant availability data as well. So even in the plant characteristic data, basically the design specification, the loss factors, the fault which is happening, and these are something which is not very uniform every day, which is completely non-uniform over the day and even over the space as well. Even when we were studying some power plant data in some solar park, for example, if you take a 20 megawatt solar park, which is like 5 megawatt of 4 blocks, even these 4 blocks were giving or generating in a different scales. The specific yields were actually varying even up to range of 10 percentage, even in these different blocks which are situated in the same location, or even with the same specifications. So the weather forecast models probably might be giving the accurate predictions, but once it is giving as an input to the energy forecasting models, the challenges in the energy forecasting models are much more complicated, and that is more specific to the power plants. And I think as CMD Posco was mentioning that the decentralized power plants, more like in a rooftop power plants, it is going to be more challenging because it is more like scattered in terms of kilowatt power plants. So the constant monitoring and maintaining the accuracies of the calibrations and the predictive maintenance is very much important in case of bringing more bringing more accuracy in the energy forecasting models. So to put it in nutshell, there should be a monitoring discipline to be required in the to bring more accuracy in the energy forecasting models, and also the inclusion of smart monitoring and quick rectification of the faults which are happening in the field. The next point, I think my earlier speaker has given a preview of that key. The regulatory aspects are very important because that is what which is mostly driving the commercial the business. So I think the CRC has already introduced the provisions for forecasting the solar and wind power under the Indian Electricity Grid Code way in May 2010. Uh, I think that is a very good move. And recently, as sir was mentioning, in 2015 there is a framework, and in March 2022, I think there is another notification on the deviation settlement mechanism, which objectivize that the regulations need to ensure through a commercial mechanism uh, that the users of the grid do not deviate from and other to their schedule of drawal and injection of electricity, which of course is in the interest of the security and the stability of the grid. So there are various I think the mechanisms given for the wind solar seller, the payback and also the return back. I think sir has already mentioned that the percentage levels like 15% and 10%. But I think it is very good to see that the regulation is also in place for supporting aspects in the RE weather forecasting. Finally, some light on the requirement part to have a good RE weather forecasting. The basic technical requirements would be from the hardware perspective, especially smart meters to monitor the real-time power productions, the weather sensors to continuously monitor the changes in the weathers, like we need sky images, and the in case of solar or even turbine, the sensors to monitor the functioning of these power plants, the regional networks of weather stations to continuously monitor the weather patterns, the satellite data. Of course, all these need to be properly captured in line to the respective IEC standards so that the accuracy of the data is always maintained. There are other software requirements, of course, to add like advanced weather forecasting tools to predict the historical data based on the historical data, and also the to predict the power generation forecasting tools and the data analytics software. So the requirement part is also very important in case of RE weather forecasting. And from the regulatory requirement, I think sir has already mentioned we have a regulation in place, so I think that is very welcoming. And we need to have more like a common open databases of weather data, which can be accessed at a minimal cost to the user, so that probably it could help the asset owners to bring in more accurate models at the decentralized level. So I think these are a couple of points which from my side I want to share. Thank you, sir.
Thank you, Nikhil. That was a nice overview of the perspective. Now I request Professor Ashwin from IISc Bangalore. Your slides are seen, but you're on the third slide or so. You're not audible.
Am I audible now? Am I audible?
Yeah, now you're
Yes,
audible.
sir.
Yeah.
Yes, sir, you're
Okay.
audible now.
Okay, and you can see my slides in the slideshow mode.
Yes, very much.
Okay. Thank you. Sorry about that glitch. So good morning, everyone, and thank you, Dr. Ashrit and Dr. Mukhopadhyay for the very kind invitation to participate. We've been mainly considering some features of renewable energy generation related to their complementarity, and that is what I will share. May I take about 10 minutes?
Yeah, that should be
Okay.
fine. Yeah.
Okay. So in speaking of renewable energy, I will highlight primarily wind and solar. Here's a diagram from the latest assessment report of IPCC, Working Group 3. It shows the potential for emissions reductions by 2030 in the energy sector, where clearly on the top, wind and solar are the dominant contributors. And the colors indicate the mitigation cost per ton of CO2, and the blue shades indicate cheaper than the reference fossil fuel generation. And it's clear from the upper two bars that a large fraction of cheap wind and solar exists, and this largely owes to substantial reductions in renewable energy generation costs in the past few decades. Now, on slide 3, this figure shows maps of the annual average wind speed and solar irradiance on the left and the right panels. And these are, of course, what mainly govern the generation of wind and solar energy. Mr. Narasimhan described the atlases. These figures show a very similar pattern. These results basically describe the average over many years. And one can see from the panel on the right that annually there's abundant solar energy throughout much of the country. There's also abundant wind in many regions, especially southern and western India. But the wind resource is highly seasonal because it's strongly tied to the monsoon flows near the surface. And so these are wind speeds up at 100 meters above the surface. Very roughly hub heights of wind turbines. And I should say that in this work, we've benefited greatly from the in situ measurements from NIWE for validating many of these results. And the two boxes that you see in these figures that have been highlighted illustrate two regions, which we'll describe a little more, where there is both abundant solar and wind. So here is the seasonal cycle of solar and wind generation. The red curves show solar generation, which depends mainly on solar irradiation at the surface. So you can think of the characteristic pattern in the two regions, in the two boxes shown in the previous slide. You can think of them in the following way. It's mainly the seasonal cycle of solar radiation, which is more obviously in the summer months, being interrupted by increased clouds during the monsoon. And for wind generation, it has a much stronger seasonal cycle than solar, with very low generation outside the summer monsoon. And owing to these typical seasonal cycles, we see very different patterns of the complementarity between wind and solar. In Rajasthan, on the left, solar decreases later in the season, with wind decreasing at about the same time, whereas in South India, solar decreases much earlier in the season when the wind is actually increasing. And owing to these seasonal patterns, there is different complementarity between wind and solar in South India and Rajasthan. The big figure on the right shows the coefficient of correlation between wind and solar generations. There's negative correlation between wind and solar in South India, positive correlation in Rajasthan. So wind and solar are complementary in South India. And I should add that this is not just because of the seasonal effect from the characteristic seasonal patterns shown here, but also occurs if you look at individual months. So the plot on the left shows the results for July, when in the mean picture, the wind speed does not change very much. So even on a day-to-day timescale, there is wind and solar complementarity in South India. And this appears to be because windy days are cloudier. And I will add that looking at these issues more closely and also understanding implications for energy sector and renewable energy integration, there's a lot of work to be done. We've barely scratched the surface. Why are we considering the correlation coefficient? Because a negative correlation coefficient reduces the variability of the total wind and solar generation. So in summary, there's a strong seasonal cycle and different patterns of complementarity in different regions. And this is important for managing variability of renewable generation. Another challenge is, of course, days with low generation. On days in which the average wind speed is small, of course, generation would be lower. Wind turbines have something called the cut-in speed, at which blades start to turn in roughly 3 meters per second. And these plots show how these drought days, when the average wind speed is smaller than 3 meters per second, are coincident. In the left panel, you see that when the northwest has a wind drought, the probability of drought in South India is small. Likewise, in the right panel for droughts in South India. So when South India has a wind drought, the probability of a drought in the northwest is small. And we need to understand these regional complementarities further. And one role that the nationwide transmission system can play is in allowing these complementarities to be deployed wherever they arise. Now, solar energy, especially through PV installations, is probably going to play the major role in the renewable energy composition of the future in the country. And solar droughts in general are much rarer, but when they do occur, they tend to be more spatially widespread. That is, they occur over larger spatial extent. And here too, wind plus solar can reduce the spatial extent of these droughts. And in hybrid installations, there is a form of redundancy which provides enhanced complementarity across different regions. So if you look in the panels on the right, in the combined hybrid droughts, the droughts are sustained over a smaller area, and it's more easier to find a region that's further away where there is less likely to be a coincident drought. Now, let's turn to another feature, the Dino Cycle. It's well known in meteorology that wind speeds have a diurnal component. That is a 24-hour cycle that can be found by decomposing the hourly wind speed into different frequencies. And this plot shows the map of the diurnal component amplitude. This Dino cycle is generally higher in lower latitudes, where there's more heating from solar radiation. The Dino cycle is also generally more pronounced over land than the open ocean, because land heats up more easily during the day. It's also found over deserts. It's found over orography over tropical islands. And in this global figure, the Indian case might not appear to be the most striking. However, in this region too, there is a moderately strong diurnal cycle of wind, including in the high resource regions of South India. And this is not limited to the wind speed at 100 meters above the ground level over land, but also in the surrounding coastal ocean, including notably in the Gulf of Mannar, where offshore wind development is planned. And the figure on the far right shows the timing of the diurnal cycle. That is, at what time of day, on average, does the 24-hour component reach its maximum? And the figure is quite messy, but it's not random. It's quite systematic with a similar pattern from year to year. And that plot I had not shown here, but what this shows is that the diurnal cycle is not merely following the sun. And on the top left is the monsoon average wind speed in two locations at roughly the same longitude. So not only do these two locations have a strong diurnal cycle, but they're also spaced roughly 12 hours apart. And the figure on the bottom shows the implications, specifically the benefits of taking into account this timing, especially when you aggregate locations with a widely separated diurnal cycle. For smoothing hourly wind generation. So the bottom panel shows the implications for hourly wind generation. And it's well known that as you choose sites for wind generation that are further apart, that are at increasing distance, you get a geographic smoothing effect. And that's the blue curve. At increasing distance, the combined generation from two sites has reduced variability. But the red curve illustrates the additional benefit from considering also the timing of the diurnal cycle, especially if you consider two sites that have a large difference in the timing of the diurnal cycle. For example, with a morning peak in wind and an evening peak in wind. And here's another area where we think there's a lot more work to be done with potentially important implications for renewable energy integration. Let me conclude by highlighting a couple of papers that we have not been involved with, but that are very relevant to our discussions today. One of the challenges that we face as we decarbonize the country's electricity grid is to understand how climate change can affect the renewable resource. And on the left is a recent study from IITM, which shows how wind and solar energy are likely to change. And this figure shows a reduction in solar energy in a warmer climate as a result of increased cloud cover. And on the right is a plot from a study that envisions a zero carbon electricity system for the country and asks how we can manage variability in solar and wind through a combination of energy storage, having interregional power exchanges, and so on. And there's a lot going on in the figure, and I don't intend for you to read it, but if one studies the paper, the overall message seems to be that all options must be fully explored. Thank you very much. I will stop here.
Thank you, sir. That was very insightful and interesting. And now we have come to the end of presentations from the invited speakers. I think we can have one round of remarks from head NCMRWF and Director IITM. Can I invite Dr. Ashish Mitra? Maybe Dr. Krishnan can give his remarks first, and then Dr. Mitra can join. We have a couple of minutes before we go into the panel discussion.
Is there any questions from anyone? You can ask.
Yeah, I was just checking on the YouTube as well as Facebook. We don't see any remarks and questions so far.
There is one question came actually. See this.
Can read out.
Yeah, CMD Posoko was mentioning, in spite of good potential over the Eastern India, but there is not much, not many farms, right? So, is there any specific reason for not having so many?
Actually, it's nothing. It's nothing. It's just the resource quality. The Rajasthan and Gujarat, the resource quality is much better, and of course, land availability could possibly be one issue. Like Bihar, West Bengal, and all these places. But definitely Odisha and all, I think definitely we could explore. There would be land availability should not be a concern. But
Right.
yes, the diversity is what we should capitalize. Otherwise, on the one hand, we talk about one sun, one world, one grid, but we are not actually utilizing the diversity for one half of the country. All the solar is on the west, and that plays a very crucial role during winters. Like winters, we have a ramp right from 4 in the morning till 11:30. There is a ramp over 7 hours, and that ramp is growing due to two reasons primarily. One is the agriculture load shifting that is taking place from night hours to the solar hours. That is one reason, and definitely the farmers they would like that they get supplies in the early morning, so that they could start their activities. That is one. And second is during winters, heating also is one issue. Electric heating, and of course, as domestic cooking, we start having more and more of electric cooking. This morning peak is going to rise. So we are going today currently, 70 gigawatt we have to climb, from 4 in the morning to 11. And all the solar is on the western side. And after 8 a.m. only, solar starts contributing to this ramp, and so between 6 to 8, solar offers no contribution. But if we have solar resources in the eastern part of the country, that would, come to the rescue.
Thank you, sir. Thank you.
Just I agree what Nasim is saying. If you see in Indian context, Partha? So just to add to what Nasim is talking about, if you see Indian context, we have seen a diversity of close to 2 hours between the far east to the west. So definitely we should start looking at a particular part of it, and some kind of additional measurements and some kind of resource mapping need to be carried out in the east and the northeast to associate the investors.
Raghu, should we start the panel?
Yeah, I think now we should start the panel discussion. We have 4 participants from the industry, representing the industry. Mr. Amresh Khosla from Manikaran Analytics. Amresh already introduced himself. Yeah, he was in the morning. He was already present. And we have Abhinav Saxena from Adani Group. Yeah, Abhinavji, yeah, he's already there. Amresh is there. Yeah, Amresh. And additionally, we have Vishal Pandya from RE Connect. Vishal, are you there? Have you joined? Yes, probably he will join in a couple of minutes.
Yeah, he's there actually, but maybe muted.
Yeah, probably like he had some connectivity issue maybe in the morning. And additionally, we have Dino Vishwanathan from Greenco Private Limited. Dino, are you there? Have you joined? I think we can. Yeah, Vishal Pandya has already joined. Vishal, can you confirm you're able to listen to us? We can't hear you. I think we can get started. In between, we'll join. So Vishal Pandya as well as Dino Vishwanathan, these 2 other panel members, they are also here. So Partha, you can take over from here. Dr. Mitra sir is also there, and Krishnan sir is also there. You can get started.
Fine. So what we will do that we'll go around and we will request each panelist to say around 3-4 minutes about their views and so far whatever we have discussed. So can we start with can we request Dr. Mitra, head NCMWF, to give your remarks, whatever we discussed, and your views about the future pathway in this weather forecasting.
Yeah, am I audible, Partha?
Yes, very much. Please go ahead.
There may be some background noise, so please excuse me. I'm in another meeting.
Okay, please go ahead.
Yeah, it was very nice that all the top scientists and executives came and expressed, and now we have more updated information from the real top persons. What is the need? And I'm thankful to all the 4 speakers, and thanks for coming over here. And as I said in the beginning, we have been interacting informally, sharing the data for last many years, like at least for 5 years. And now it's taking a shape. So I was thinking a parallel, like the application of weather and climate forecast we have well established in hydrology, in agromet. So we have named like hydromet, agromet, and air quality. And now it's time that we have to establish dedicated cells in our department, ministry, and institutes, something called energy met. Because, and 2 things have happened. The industry matured, they are using the technology, and at the same time, the skill of our forecasting has improved. It has improved, but much more is required. So that's one thing. We'll go back to our ministry and talk to our secretary that dedicated cells in each institute is required to cater to the energy metallurgy that nexus, one thing. And we have been talking, as I said, to many of the company's executives. So we understand there is a requirement of much like high resolution, more accurate forecast. And you have to take it from us that from the ministry side, the institutes, IITM and NCMWF, we are developing model, and we have the capability and our models are state-of-the-art, world-class. So when we talk to application or users like you, we understand that what is the requirement, and this developing customized model is a new work now. So the modeling framework is there, and what we have a general model for weather forecasting that meets all the users that we have been doing. But now time has come that if extra resources are allocated, then we talk to each customer, like wind energy, solar energy, their requirements are different. And POSOCOs and now this uh, other private companies are also talking to us. We understand everybody's requirement is different. So like I said, hydrological application, agricultural application, air quality. So this is a full-fledged application where the economic benefits and the societal impacts are immense. So we'll take care that we start dedicated cells in our institutes for looking after the need of the energy sector and what resources we need. Another discussion was there. I heard you have solar park. We have similarly observation test beds. So what we can do, we can have a pilot observation area adjacent to your park. It can be a solar park, it can be a wind energy park, and validate our models there and develop customized model for the small regions with typical characteristics. So that will help both the community, model development and your application. So that is another thing, like we have test bed, we'll recommend that we come up at wherever there are parks, wind energy special zones or solar parks are there, we establish our weather forecasting test beds and observing test beds there. And we'll be interacting more. So more and more if we interact, and I am sure the customized forecasting or modeling capability will come up. And another thing I would like to add here that Dr. Narasimhan was talking about the uncertainty, single forecast 2 times a day. But last 3 years, we have been doing this ensemble forecasting, global and regional. And another thing, we are using coupled model for extended multi-week up to 4 weeks. That will give you some guidance what's going to happen. So we have to meet more frequently, express our needs and what can be done, what cannot be done, what can be planned now, so that we start getting result after a year. So that is another thing, how to use more and more this ensemble forecasting so that the uncertainty is also built into your tools, what you are using for grid management, transmission planning, etc. So with that, I will stop here. Thank you once again to all the 4 speakers, very excellent information and good talks. Thank you very much.
Thank you, Dr. Mitra, for your all insightful comments. And may I request Dr. Krishnan, Director IDM, to give your remarks and opinion. Dr. Krishnan. He's not there, or what, Raghu? Then can we move to Professor Ashwin? Can you give your remark as a panelist?
So I'm not an expert on numerical weather prediction or a simulation, but I can say, based on the kind of work we have done on integration, that it's very timely to explore, how NWP can be applied to generate products aimed at the renewable energy sector. And given the large-scale nature of the phenomena that are producing renewable energy variability and extreme events such as energy droughts, I think it would seem to me that products based on NWP models would remain central to the forecasting effort. But that being said, there's a clear need for applied products at various levels, from the generator up to pooling stations all the way to the national grid. But translating what we learn from NWP to these different users might end up being different problems with different information needs. One specific point that I can make is that the effect of scale might cut in various ways, in ways that might end up being surprising. So for example, if there's a strong Dino cycle and one seeks to make an aggregate forecast for sites with largely different Dino cycles, where the timing of the Dino cycle is different, then one might lose predictability through aggregation. But in other ways, aggregation can have advantages if the individual forecast errors are uncorrelated. So I think there are many issues that we've barely explored, but these should be examined very carefully. And I think there's scope for extensive research and industry interaction on all of these topics. Thank you.
Yeah, thank you, Ashton. Very nice. Excellent to hear you are emphasizing on the diurnal cycle, which is very important, and all model actually struggle in capturing the diurnal cycle. We know it very well. So may I request Dr. Balaram, please, to comment, give your final comments.
Thank you, Partha. I think it's covered a good aspect of it, but only a couple of points I want to emphasize. See, one is model, other one is measurements. Because model can definitely play a role, but measurements is also an important aspect of to validate the models. This is where I find some kind of a discontent in the system what we are trying to see here. In fact, we are trying to propose the mesh of the network models, network measurements of things in the country. Because as we move towards the 500 gigawatts, already proposing to our ministry, and also we need to start pitching in along with your ministry to start the measurements at a different area, so that this is very important. Because some of the signals, very recent papers coming out saying that wind and solar is coming down in the country. This is giving a negative phenomena for the investors. And we had a lot of issues coming out in the last couple of months, right? From even in the parliament, it's been talked about, and we had a question saying that is it true? If you try to talk about the wind generation, if you see, yes, this is cyclic phenomena is there. But if you're trying to say whether it's going to be dropping from say 2000 to here, but when you see on our Kayata side, we are not seeing that. These are the things which are models say correct. It may give some kind of the things. It all depends upon how you're going to interpret the model. Sometimes the interpretation is going to make such a mechanism which is going to see the negative aspect is going to come out. This is one area of concern I want to put in this platform. Let us start working out. Let us see the model, and also the measurements is an important aspect of it. I would say the measurement is on the weak wicket as of today. So we need to start focusing on that, because even today, in the solar, we have close to around 10 years of measurement in a single location. But as a wind, we don't have a single measurements at a single location for number of years, maybe 2 years or 3 years distributed. Then we may have to rely on the error data or mirror data. Again, it's a reanalysis data. Again, we cannot say that with the certainty this is what is going to happen. And taking the data and coming out in the perception saying that wind is going to come down, solar is going to come down in the future, it will be far-fetched that it's going to create the electricity limits. I think we need to start working on this phenomenon also.
Yeah, thank you, Dr. Balaram. Actually, that paper what we wrote, basically, it's the possibility. We're not, telling exactly what will. It's a kind of possibility which is coming out based on these CIMI-5, CIMI-6, and Cortex, 3 independent modeling system, unanimously suggesting there is a 10 to 15%, and which goes consistent with IPCC, which says that in an enhanced polluting and more aerosol, the cloud lifetime may increase. So these are all kind of possibility. It's not absolute certainty. Model has its own uncertainty. But as you said, that definitely measurement and model, they should go hand in hand. I fully agree with you. So
just to add a small point here, in fact, this is the one phenomena we saw in 2020. If you see in 2020, the wind generation has come down. There's a lot of panicky reaction we created, saying that almost close to 30% drop in the wind generation is there. In fact, we said in the model in the month of April, so we said predicted in this year wind generation is going to be on the lower side, and on 2021 the generation has really picked up. So this kind of variation is going to happen in the phenomena.
True, very true. Request Dr. Nikhil from Solar Energy Institute. Can you give your final comments on the proceedings?
Sir, as I was mentioning that both the weather as well as the energy forecasting is also important, because from the perspective of technology evolutions, there has been various technologies evolving, especially in the solar, say bifacial technology, and also there has been patterns of installations where the developers are trying the east-west axis of, so that will make the generation curve also or the profile also different, Unlike what we see in a single peak for a solar, there could be two peaks which is happening. So I think that is also contributing to the uncertainties in the overall forecasting ecosystem. So as rightly told by DG Nive, measurements is a very important aspect, reducing the uncertainty and ensuring the calibration of all these measurements is very, very critical. And apart from that, inclusion of the technology aspects is very important in the forecasting. Thank you, sir.
Thank you, Dr. Nikhil. May I request CMD Posoko, please, to give your final remarks, sir?
Yeah, thank you. See, first of all, I would like to thank Professor Ashwin also. Like the two papers which he has referred, definitely we would take a look at that, on what is the future potential, moment we are talking about net zero and all that. So this is one fear which we also have, that solar generation, especially in Rajasthan, we are having too much at one place, like either in Gujarat and Rajasthan. So tomorrow, when if suppose sandstorms or some such phenomena take place, we might lose a good chunk of generation. So that's something which is we need to be aware of these things when we are looking at 500 gigawatt and beyond. So we'll take a look at those papers, and I would like to thank Professor Ashish Mitra also for his suggestion of having energy met, just like agromet and others. So that's something on which definitely, and we are working in that direction, like just we had renewed our MOU with IMD, and Dr. Mrityunjay Mahapatra was there at our office also. And so we are now going to the next level of, earlier the qualitative level forecasts that were, something we looked at that in the initial years of our MOU. But now moving towards a quantitative more analysis, and whatever IMD's weather stations and all that, how can we get information, the forecast for our solar and wind? We are trying to look at that, and what Dr. Ashish Mitra talked about test beds, that actually may not be required, because in this IMD MOU, what we have done is, because we are all getting the real-time data of wind speed, solar irradiance from the field, from the solar park. So all that data we are getting in real time. So we are developing this thing of sharing it with IMD, so that they are able to correct their forecasts, and improve their models also, So that's something which is very much on the radar, and that would really help all of us in having better forecasts. So thus on the NWP, I just had, so the general feeling is that more frequent updates to the NWP model is difficult because there's a huge computational burden, So if my colleagues from NCMWRF could, share on the developments on that front, whether is it at all required or not, do frequent updates to NWP runs, would they help, or would it be just, unnecessary computation? So maybe on that, if something is shared, that would benefit all of us. Thank you.
Yeah, thank you. Thank you, Mr. Narasimha. Actually, with your Western Regional Load Dispatch Center, WRLDC, we have a MOU with IITM almost 3 years back. Sachala Mr. Madam and Mr. Raghuvanti. They are using our GFS model every day. It is, pushed to their system. And I think regarding this cycle, see, normally Raghu is there and Dr. Mitra also is there. So the global model assimilation cannot be done more than 4 times a day. Okay, because the data that is observed in 4 synoptic hours, 0, 6, 12, and 18 UTC, those are assimilated and then the model are run based on that. So even though theoretically MNRE requirement says that 16 times or 12 times or whatever it is, but for an operational system, assimilation system, more than, I mean, that is the practice not only here, it is there in ECMWF and everywhere globally. So in a day, 4 times the assimilation cycles are run. That itself takes a huge computation. 0, 6, 12, 18. That's how, I think for our ensemble model, we just run two times a day, 0 and 12. So that's one of the limitations from the our, I think, operation. So Dr. Mitra has mentioned in the chat that in cyclone, heavy rain, etc., we have a rapid update cycle, and that is on demand based. Yeah, that's true. I mean, when there is a, like a disaster and high impact weather system, then there is a rapid update cycle. So that is run, but that is not run every day on every, so that based on requirements, etc. But thank you, sir, for your very insightful comments. So may I now go to our stakeholders from Manikaran, Mr. Amresh.
Yeah, good morning, everyone. Amresh here from Manikaran. As I could able to see, and we all have already got a lot of insights from the industry stalwarts, specifically from POSOCO. So our pain is same as is the for the energy sector. So we are the service provider for energy sector in order to provide the forecast for renewable energy, wind and solar, wherein we are currently handling around 35 gigawatt of entire capacity across India. So handling such a capacity with small and large capacities, I can emphasize on that the capacities that we are handling is as small as 1 megawatt in Gujarat and as large as around 300, 400 gigawatt across the CTU connected plants. So the main challenge that we come across is like a very short-term forecast, which is not available from any of the weather department. As Dr. Mohapatra has recently said also, like it is not available, only 4 updates are available. So in order to update the recent things that we are running our internal models in wherein we are running the additional inputs we are using from the sites and incorporating it. But again, in absence of the weather inputs, which is not a revised weather inputs, the errors are really high. So if we talk about any site, like any case study that we have done for the large site of about 300 megawatt wind site, we can see in terms of mean absolute error, on day-ahead basis, the error is as large as around 50 megawatt in terms of MAE for the entire month, which is calculated for each 15-minute time block. So 300 megawatt site, the error is as large as 50 megawatt for any of the time blocks. Whereas on day-ahead basis, the same error reduces to around 15 megawatt or 20 megawatt, which is negligible and is covered under the current regulation, which allows 15% exemption. So by far on intraday basis, we are able to achieve the accuracy, but the real pain of the industry is like, yes, on day-ahead basis, they should know 3 hours ahead, they should know what is going to happen, so that accordingly the planning for the power can be scheduled. For example, nowadays real-time market is available, wherein every 6 time blocks ahead, power can be sold or purchased on the exchange platform. And these all the stakeholders, those are buying this renewable power, they have an option to do this trading on the real-time platform. But again, they need an update at least 6 to 7 blocks ahead or 8 blocks ahead, which is around 2 hours ahead. And that 2 hour ahead, as Dr. Mitra has said, maybe that energy met kind of a product which is based on the regional forecast, not a global model. Yes, a regional model, if that can be taken into consideration, which is running for, say, example, for the western part, Rajasthan, Gujarat, and again covering some of the major states like Maharashtra, MP, that would be very useful for us. And on the basis of that, the accuracy can definitely be improved. But I can see, like, we got associated with NCM somewhere in 2012, and it is out almost about 10 years. Like, we know that like what is the improvement we have got from NCM side, as well as with the common efforts we could able to achieve a long journey and reduce the errors up to a great level. And I would like to thank all the panelists and all the stakeholders here in this, and that is what I would like to convey. Yeah, that's all from my side.
Thank you, Mr. Amresh, for all your comments. Now, I request Mr. Vinab, from Adani Green.
Hi, good afternoon, or rather good morning. I hope you guys can hear me.
Yeah, clear.
Okay.
Please go ahead.
So first of all, thank you very much for inviting me to such an august panel. Some of the discussions that I've been hearing here are really interesting. What I'm going to say is also pretty much on lines with what Amresh has mentioned. So, there were a couple of points that were discussed today in the preceding sessions, wherein we were talking about ANN, we were talking about improvement in forecasting capabilities and things like that. But what we are seeing from and we are not denying that there have been improvements in forecasting methodology and approaches. But what we are seeing from the industry side is that there is still a very big disconnect between the policies and the capabilities, right? So basically, just to give you an example, there are a lot of penalty that we incur is during the months of monsoon. Primarily, this penalty is because of the movement of clouds for solar, right? There are technologies available in market where we can capture the movement of cloud either through cloud motion vectoring or through sky cams or things like that. But to assimilate this data into the forecast and then to generate a revised forecast is going to take time, right? The current methodology or the current regulations have been set up in such a way that I can issue a revision at a particular time block and it is applicable after 1 hour. The scientific technology or the forecasting capabilities do not match with this regulation. So practically, it is not possible for me to factor in the movement of clouds currently within my own forecasts and issue a more, uh, solid forecast to the operators. And this is harming both the grids as well as the generators. Because, and this is my, biggest pain point that if you consider the case of thermal generators, most of the power generation is within the control of the generators. They can control the operations of their plant. They can control the maintenance activities of their plant, and there are very few things that are out of their own control. Whereas with renewable, most of the factors are beyond my control. I cannot do anything if the wind is not blowing, but still I will be penalized. And that is the part where I think the regulations are not in sync with the realities. They are not in sync with the capabilities. There were some very interesting point mentioned by Dr. Mitra, and I am, actually quite in favor of what he has been proposing, although with a slight modification. So definitely there is a need for an energy met department because, like Dr. Mukhopadhyay pointed out, the revisions are available only 4 times a day. This is based on the UTC time. So essentially for India, there are only 2 revisions that are actually applicable to me. The one at 5:30 in the morning and then the one that happens later in the evening. The other 2 revisions, they are from a solar generation perspective, the other 2 revisions also are not, going to add any value. After that, what is going to happen is, there will be time taken to process this data and to generate NWP model outputs, which will then be consumed by us to generate a forecast. So there is a huge lag. And again, the regulations play a spoil sport there because I have to submit my forecasts depending on state or, the SLDC or RLDC you are dealing with, either by 7 a.m. or by before 10 a.m. So I have very limited time in which I need to process this data and provide this. And this is something that is not working out for us very well. And so we need a dedicated agency within our country which is able to, maybe generate specific country specific numbers for us well within time, right? The other point that he mentioned, which was about the test bed, I find that point very interesting because lately what we have been seeing is there have been large areas of land that the government is developing as solar park or renewable parks. And I would be bold enough to slightly modify what Dr. Mitra has suggested and recommend that why can't NCMRWF or IITM play a more dedicated role and set up monitoring stations within the park and generate forecast for the park. Because one of the things that within the industry we have been discussing and debating is sharing of data. Each of us, each operator within the park has set up their own weather monitoring station. They are capturing their own weather data with whatever means that are available to them. And even if I apply the most basic of game theory, then everyone is trying to maximize their own individual gains, whereas collectively we would have been much better off, right? So in these sort of projects where the government itself is taking an initiative to develop such a large area for solar power, why can't we even develop that forecasting capabilities for the plant itself? Even if the weather data is available, the conversion from weather to power is something that most of the operators will be able to manage. So, but weather is mainly where the problem is, right? And then one of the things I think Dr. Kannan had mentioned was developing a grid-based system. I think that is, that is an idea that is already very late, but it is very, very required, because what we are seeing is that the quality of data or the quality of ground level data impacts the weather forecast significantly. And it is not just from a operator's perspective, it is not just GHI or wind speed forecast that we are in need of. We also need rainfall data, because our sites tend to get flooded. I need to plan my operations such that if there is heavy rainfall or something, I need to evacuate my own staff from those sites, because otherwise they will be stuck in a remote location with no means or help available. So that kind of information is also required for us, and uh, we means the private sector is very, very interested, or at least my organization is very, very interested in collaborating in whatever way possible to develop this infrastructure. But ultimately, if you look at it very objectively, this has to be an imperative of the government. And just as a final point, I was in past couple of days, I've been reading few articles wherein either people have been criticizing IMD for the lack of the accuracy of their forecasts, or I think Dr. Mrityunjay Mohapatra had also made a statement about the impact of climate change, where a lot of discussions were happening on social media. But I really empathize with IMD, because if you look at the budget, the US Weather Service, they have a budget of around $5.9 billion as compared to IMD, which has a budget of only $64 million. So we are like around 1,000th of their budget. And even if you say that India's GDP is not as large as US GDP, and even if you normalize it that way, we are around the same number. So around 0.025, I think 0 to 5% of US GDP is spent on weather, as compared to 0.05% of Indian GDP. So the government agrees that weather is very important in almost all spheres of life, whether it is agriculture, whether it is real estate, or energy generation, and yet we are not spending as much in that area. And so, with the help of your forum, if there is one message that I really want to be communicated, it is that it is high time we need to spend more on weather now. That's all from me. Thank you.
Thank you, Mr. Amina, for your very insightful and detailed, opinion and comments. So we will definitely take some of these into the final recommendation, that will be prepared. And now we request Mr. Vishal, right, from Reconnect to give your
Yes, sir.
remarks. Yeah, go ahead.
Yes, good morning, everyone. Very glad to be here. Also, an apology for running a little late. I had different time slot for some reason marked in my calendar. So I would agree with what Abhinavji just said, that there is investment required, understanding weather is basically a real god, even if you are an atheist, right, which impacts your day-to-day livelihood, all forms of assets, I mean energy, infra, the natural resources. And of course the accuracies are improving, but the ask from the weather and the people who are building temple around weather, IMD for example, right, the ask is increasing, ever increasing. We are doing RE forecasting for about 100 gigawatt of assets between various control centers and private asset owners. Demand forecasting again for equally sizable magnitude, where the impact of weather is there for everyone to immediately see. For example, if you take case like Haryana, the state which is heavily dependent on agri, if there is a large patch of rain, the demand will drop by 50-60% in a day. And then of course the weather model will indicate that there is a certain degree of rain, but what happens most of the time is that either you miss by a time magnitude or by a geographical magnitude. uh, in a large city, if there is a rain event, the demand will collapse. Like if I take example of Karnataka, Bescom constitutes 50% of Karnataka's load, and Bangalore to the extent maybe 40-45% of Karnataka's load. If there is a large or heavy rain in Bangalore, the demand will go haywire. Right. Same happens with the cloud movement, the wind gust events, and on intraday basis, the AI takes over compared to what your day ahead predictions are. But from the grid operations point of view now, more and more demands are coming, and Narasimhan Saab also would agree that day ahead basis, week ahead basis, especially the power procurement, the scheduling, the resource management, the transmission network adequacy assessment. So a lot of areas where now the requirements are coming, where it says that give me similar accuracy weather forecast or RE forecast or demand forecast on a day ahead basis or week ahead basis. I mean, there are scientific limits, like we discussed, that how difficult it is to go beyond 4 weather runs. But it is also equally important to kind of focus on the quality of data. What are other tools available? And from the market's point of view, we are going closer in terms of real time. We have RTM, which is 6 time block ahead. Perhaps with 5-minute time block coming in place, we might have half an hour ahead market. But within these constraints, between the science, the infrastructure, like the computational power, the new data sets which may come from satellite, which may come from weather satellites. I mean, what more we can utilize in order to meet the industry requirement? And here we are gathered to talk about energy specific problems. The generation asset, the demand behavior is location specific. The time horizon is very small. For example, we are operating in 15-minute granularity. Predicting the movement of a cloud or a wind gust in that 15-minute time frame, maybe moving to 5-minute time frame, it's going to be challenging. And I don't have a clear answer or solution to this, but the requirements are very clear, and it's ever expanding by multiple actors across the industry. And any collaboration, any kind of innovative collaboration models that can come up between NCM, RWF, IMD, maybe creating a more open data sharing framework which can help improve the understanding of weather would perhaps take us long way, right? We are talking about the normal weather from the forecasting point of view, but the extreme weather is also equally important. And how do you minimize the impact of extreme weather on your transmission assets, on your resources, on your other infrastructure, which may not be necessarily connected to the energy industry, but all these aspects are very, very important.
Yeah, thank you, Mr. Vishal, for realistically addressing all the model issues. Raghu, you wanted to take some snapshots. Should we request everyone to switch on the camera?
Yeah,
If
before
you all
we
can
go ahead,
kindly
yes.
switch on the camera and so that, yeah. Still, Mr. Dinu. Still, some cameras are not on, it looks like. Right. Is it okay, Raghu?
Yeah, we'll take at least with like anybody who is already there, we can have one click.
Okay. Okay.
Yeah, I got one. Fine, thank you. I got another one.
Okay. Thank you. So now,
go ahead.
yeah, what do you say?
Yeah, we can go ahead.
Okay. So now can we request the last panelist from Greenco, Mr. Dinesh, right?
Dino Vishwanathan. Yeah, not
Dino,
audible.
Yeah. You're not audible, yeah.
Yeah, very good afternoon. Very good morning, everybody.
Morning, yeah.
Thank you for giving an opportunity to be part of this panel discussion. Actually, I use this my proud privilege to give a thankful to all the AK Mehta sir, Raghu, Dr. Raghu, Dr. Sushant, all are giving all this support. So we Greengo have a currently 7 gigawatt portfolio all over India. So we are under pipeline of some IRESP projects also. Very soon it will be also coming to effect by couple of years. So we are getting support from NCMRF since last 2 years. We are utilizing the NCMRF models from through FTP data since last 2 years. So based on the NCMRF model, what sharing by NCMRF team, we have developed our own forecasting system along with the renowned other forecast agencies like RE Connect, Manigaran, and other some global agencies. So our forecasting, the algorithm also got an accuracy of 87% for the wind farms last year and 93% of accuracy for the solar farms last year. So after so many discussion in continuation with Dr. Raghu and Sushant, we have requested to, many people already suggested to increase the frequency of the data what we are getting from NCMRF. Currently we are getting 2 times per day, one is 0 UTC and 12 UTC. So after in discussion with the team, we have requested whether if it is possible to increase the frequency of the data. So currently, if you look into the current market, is the most of the times some scheduling is happening in day-ahead markets also. So it will be very difficult to predict in the day-ahead market with TAM, DAM, and RTM and all. Even after getting a 16 revisions, we are in the range of 93% of accuracy, almost. But a few times we are getting 100% also. But on an average, we are getting 93 for solar and 87 for wind. So this is sometimes it got fluctuated also based on the weather models also. If it would be a kindly request from our side also, if possible, NCMRF can give improve the frequency of the data what we are getting through FTP. So maybe it will improve our accuracy based on that also. But we are very thankful for the entire NCMRF team for giving such an opportunity to get the data through FTP since last 2 years. So we also, every month we also used to share our feedback to the NCMRF team also. Thank you, sir.
Yeah, thank you, Mr. Dinu. So we have come to the conclusion, end of this panel discussion. So Raghu, do we request anybody else present to give any comments who have not spoken?
We can just keep it open for any other participants.
Anyone?
Any
Like
there are some comments on the chat box regarding what Dr. Mitra had mentioned. Amresh Khosla is expressing his agreement. Like, we do agree for the PPP model in order to get improvised forecast for renewable energy. That is his remark. Yeah, Vishal Pandey has also sent a message. Sorry for that. So there are no, actually on YouTube also there are no comments. YouTube and Facebook I have just checked. There are no specific comments or remarks or questions. Just we can throw it open to all the participants if anybody desires to share their views.
Because you want to share some thoughts?
Yeah, Vishal is raised.
Vikas Aswale from Suzlon.
Sir, first of all, I would like to thank you to all the presenters for giving a nice presentation, insightful presentation. And we are looking forward to work, closely with IITM and, improve accuracy of forecast. Thank you.
Thank you, Vikas. Anyone else wants to go? Yeah, Mr. Vishal. Yeah, please go ahead.
Yes, I have a question for Dr. Balram as well as for Dr. Mukhopadhyay. In terms of the data and the data availability, whether we all want more accurate day ahead, week ahead, intraday forecast, in order to kind of understand the implication of past observations, and Dr. Balram was spot on that the measurements play a key role. Now, if you look at NIWE's own database, NIWE has invested significantly over years to get real observations from various metmast. The data is also available on a procurement basis, but there is no real mechanism to have close to real time or even once a day streaming of data. The current process is you apply for procuring data, you get it in a bundle either in form of CD or some transfer. Same is the case with other meteorological agencies. If there is any protocol being created, either through NCM, RWF, or IITM, or NIWE, where the actual observations of the sites where the metmasts are installed, which can be procured by companies like us as well as stakeholders like say Greenco or Adani, it will help open up the data in a larger way where some automation can kick in and larger benefits can be derived, not only in terms of understanding the resources and resource availability, but also perhaps going deeper into the weather modeling by various stakeholders where site specific models can be developed, and that would perhaps help all the stakeholders in a long way in terms of understanding real weather which prevails. Today what we end up doing is we look at the actual power which corresponds very closely to actual weather, whether it is wind or solar site, and we do that reverse transformation to estimate the weather at each site and do a different analysis on that. So that is one just a suggestion since all stakeholders are here, and it's also a long pending demand to kind of course we are grateful for NCM RWF to have the data being shared on a regular basis, but we are also part of certain critical infrastructures like REMC and all, and one of the contractual requirement there was that the weather forecast data should be procured. Now, in absence of not having any procurement contract, we could not use NCM RWF data in infrastructure like REMC. And many such opportunities would come up. So if there is any commercial arrangement that NCM RWF can come up with or IITM can come up with, it will further enhance applying this data into many commercial contracts, not only restricted to REMC, but maybe various other infrastructure layers where weather becomes an important element of your decision making. So these are the two specific inputs and suggestions I have for the key institutions like NIWE and IITM and NCM RWF. Thank you so much.
Dr. Balaram, you can first.
Yeah, just to respond. In fact, we are creating a portal for the data as well as the forecasting part of it. So because of the COVID, small interruptions are there, including data collection. So we're already developing a portal which is going to be like a subscription base. People can download or take the data on the real time, whatever the BitMos available. And moving forward, we are also trying to have interaction with MOEs and IMD and NCMW. We are going to have MOU, and we are trying to see very clearly what are the different locations we can have the BitMos, which is going to be unconnected. Because today, if you try to say the BitMos, we are going to have a data collector for 1 or 2 years. There's no, the permanent BitMos is available at any locations. So this is the one area we are already talking to our ministry as well as the MOEs, so that we can identify some of the key critical locations where we want to get the long-term data, which is going to be critical for the moving forward in the net zero and also the 500 gigawatts or 1000 gigawatts we are trying to talk about. This is a very important aspect of it. We are already working on that.
Thank you, Dr. Balaraman. Yeah, Mr. Vishal, already Dr. Mitra also has commented in the chat box. You can see IITM, just to clarify, IITM doesn't have the mandate to generate data. Okay, so for observational network, the mandate goes to India Meteorological Department. Okay, so if there is any network to be set up specifically that will cater to the need of RE sectors, okay, that has to be done by MOEs, IMD. Okay, IITM basically develops different models, different types of model for applications. Okay, that's what IITM. But IITM definitely now engage itself in different, setting up some test bed, and where there was some discussion that where some some specific dedicated solar park or something, along with that we can put our instrument and make an observation. So that is like a like a pilot. It's not a routine thing. But having said that, what just now I think Sushant said, there is a radiation network available from IMD, but that is all again not specific for RE sector. It is more from meteorological requirement rather than keeping the requirement of RE sector into account. So that's the issue. But you have raised a very important issue, which we definitely in our minute. Yeah. So in our minutes we'll be minute it loud and clear that this is a requirement coming up, and as Dr. Balaraman said, it is in coordinations with the new way. This has to be generated, and then there has to be a portal. First the data has to be very systematically generated and kept, and then the portal can be opened for all RE sectors to use it. Yeah, but it's a very important point that you raised. Yeah.
Thank you,
Dr. Just to add a point here.
Yeah, please.
So the need for different sectors are different. For example, for weather model, the need of the data is entirely different. So the data could be the same, but the interpretation and which kind of data to be taken, what to be modeled, it is going to be the specialist area where we need to have a specialized part of it. So this is where there is always better. In fact, last week when your secretary has come in, we had a discussion on this particular one. So we need to start working with the intermediate level to start working on this data. So instead of working in parallel, it needs to be integrated approach. It will start working.
Yeah, sure, definitely. So anyone else now wants to make any quick comments, because we are just having around 5 minutes for the session to conclude. Dr. Mitra, you want to say something on response to what we have discussed?
Actually, he mentioned that he cannot. Audio is not available now. Yeah.
Okay.
He could only hear, or he can comment on the chat box.
Okay. So anyone else left, Raghu? I am not.
Partha, just to have a small suggestion here.
Yeah, please.
Okay, as I put it in my earlier talk also. Now, since we are trying to have 500 gigawatt by 2030, is going to be fast approaching. So for that to manage, the data points are very, very critical. So we can start working on which are the critical data points. At least we can start working on these locations where we can start picking the data, so that we are not going to be lost when we are trying to talk about 2030. I think a joint effort from POSOCO and IITM, NCMWF, NIWE, nice. It's a joint effort. I'm not saying to say it's going to be the single man solving. So we need to start working on that. Identify the locations. These are the locations which are going to give a clear representation of the different places what you're going to focus on. Because today it's not just we're talking about intraday. Intraday is become very, very critical because the cloud and also the wind changes are there. And the day ahead, And moving forward, as I told you very clearly, if you talk about 2030 scenario, and POSOCO definitely need for a medium-term forecast also very important. So we need to start developing medium-term forecasting. And of course, long-term is very important. We are talking about 2070 scenario of net zero. So these are the things. I think there should be a separate working group need to be formed so that the strategic group to work on these particular sectors.
Yeah, very, very, very nice. Thank you, Dr. Baran. Actually, I was about to say that what you are saying, it means that we need a national working group involving private and public together, keeping the timeline in mind, and all those points what we have discussed from the observation and also from the model to address it, and monitor it regularly so that we can achieve the 500 gigawatt by 2030. And yeah, I mean, Mitra Sahib is telling we can have a energy met national working group, okay, where MNRE, MOES, along with all our private stakeholders and POSOCO, of course, can have it, and then we can periodically, so that we can in our recommendation very strongly, so that can happen. That can be a the next step which will come out from this iCEN-75 that can be taken forward, I think. Yeah, many thanks. So Raghu, should we now conclude this panel discussion, and should we just go for vote of thanks and conclude, because we have 3 minutes left?
Yeah, I think we are done. We are well on time.
Okay.
Thanks to all the panelists as well as the invited speakers who stuck to their time. So
yeah,
in a systematic
I'm
manner it was organized. You can just take the vote of thanks.
Okay, thank you. So yeah, it was a great event. Actually, this happened to be the last event of iCEN-75. So Azadi Kamrit Mahotsav, but I think we have it with a lot of enthusiasm. And I mean, many thanks to our director NC1WF, director IITM for guiding us and sparing their time and valuable opinion and guidance. Many thanks to Professor Ashwin, who has very agreed in a very short time and gave a very excellent presentations. Sincere thanks to Dr. Balaraman, our long-term collaborator, sparing so much time, sir, for sitting to 2 hours and enlightening us. Thanks, a lot of thanks and gratitude to CMD POSOCO, sir. Thank you so much for addressing very sincerely all the issues and sharing with us your valuable comments. Mr. Amrish Manikaran, our friend, many thanks, Amrish, for joining this, agreeing, giving your consent and valuable opinions. Mr. Abhinav, many thanks for also agreeing and echoing the same feeling of energy met, and we definitely will work together in a PPP model. Mr. Vishal of AriConnect, you raised a very valid points. We will take it forward, in the minutes as well. And Mr. From Greenco, right, Mr. Viswanathan. He also has raised a very valid and important points in today's deliberations. So I thank each one of you for sparing your valuable time and giving your kind consent and agreeing to participate in this iCEN-75, making it a great success. Thank you, each and everyone. Thank you.
Thank you, sir. Thank you.
Thank you.
Raghu, can you close?
Thank you.
Yeah.
Thank you.
Well, we can close now.
Okay.
Thanks to the participants. Bye.
Bye.